dear students, as we have completed our discussion on the chapter viscosity, let's try and solve some problems from the chapter. So, as we have already seen, when a fluid flows, it flows in different layers and there is a velocity gradient between the successive layers. That is, each layer of the liquid will flow with a different velocity and this velocity decreases or increases with length. Since these successive layers flow with a different velocity, there is a relative motion between these layers. And these create some kind of a resistance or a friction between the layers. And the viscosity is the property of a fluid by virtue of which it opposes the relative motion between successive layers. And we say honey is more viscous than water. We have seen an equation for tangential viscous force acting on a liquid which is flowing through an area A with a velocity gradient dV by dx, and it is given by F is equal to eta A into dV by dx, where eta is a coefficient of viscosity, A is the area of the flow of the water, and dV by dx is the velocity gradient. The velocity gradient can also be negative if the velocity decreases with increase in length, such as in the case of a capillary tube. We have also seen the Poisson's formula for volume rate of flow of liquid through a horizontal capillary tube of uniform bore under a constant pressure P. We have found that the volume rate of flow, that is volume per time, or Q, is equal to pi P a to the power 4 divided by 8 ln, where P is the constant pressure, A is the uniform bore or the radius of the capillary tube, L is the length of the tube, and eta is the coefficient of viscosity of the liquid which is flowing through the tube. We have seen that the velocity of flow at a distance x from the axis is given by V is equal to P by 4 L eta A square minus x square. And from this equation we can see that in a capillary tube there is maximum velocity through its axis and the velocity decreases as the length from the axis increases and it is 0 at the walls. Let's look into the first question. 5 into 10 to the power negative 5 meter cube of alcohol flows in 10 minutes through a capillary tube of diameter 0.8 millimeter and length 0.2 meter, fitted horizontally at the bottom of a vessel which is filled with alcohol. The axis of the tube is 0.25 meter. Below the free surface of the alcohol is the vessel. Given the density of the alcohol is 800 kg per meter cube, find the viscosity. So, what are the given information? We know that a volume of water, say V, is 5 into 10 to the power negative 5 meter cube is flowing at a time t is equal to 10 minutes, which is equal to 10 into 60 seconds. Now, what do we have? The capillary tube has a diameter which is equal to 0.8 millimeter, which implies that it has a radius A, that is 0.4, half of the diameter, into 10 to the power negative 3 meter. And it has a length L which is given by 0.2 meter and it is fitted horizontally on the bottom of a vessel. So let's see, this is how it is fitted, and it is fitted at the bottom of a vessel. Now, at the free surface of the alcohol of the vessel, we have this pressure and we are given with the density of the alcohol. We are asked to find the coefficient of viscosity. We have the equation, the Poisson's equation Q, that is volume rate of flow, which is V by T, the volume rate of flow, and we have the equation pi P a to the power 4 divided by 8L eta. So, from this equation, we know enough information except for P. So, how do we solve for P? What is P? P is the pressure difference. Pressure difference between what two points? The pressure difference between the initial point here and the final point here, because this is our capillary tube and this is an equation for a capillary flow. So, we need to find the pressure difference between these 2 points. So, let the pressure difference at here is just the atmospheric pressure, and the pressure difference here is what we have is atmospheric pressure plus the pressure which is imparted on this part of the liquid by the weight of this upper column. I repeat, the pressure of the liquid at this point is atmospheric pressure plus the pressure of the liquid at this point, which is imparted by the weight of a liquid column above it, and the pressure which is imparted by a liquid through a height h which has a density rho is given by P is equal to h rho g. So, this is the pressure imparted on a liquid by a liquid column of height h, density rho at a constant gravity g, which is 9.8 meter per second square. So, let's include this equation h rho g also in this and see. So, we have an equation V by T is equal to pi. Instead of P, let's write h rho g. Why are we taking h rho g? Because we have the values for g as 800 kilogram per meter cube, and it is said that the axis of tube is 0.25 below the free surface, that is h is 0.25. So, we have from the question we have h is 0.25 meter and we know the value of g. So, we can substitute pressure as h rho g, a to the power 4 divided by 8L eta. From this we can solve for eta. Eta is equal to pi h rho g a to the power 4 t divided by 8L V. We can give values for all these. We have value pi is 3.14 into, and the height is 0.25 meter, 0.25. We have density, it is also given in SI unit, so it is 800. Value of G is 9.8. We are given A is 0.4 into 10 to the power negative 3 the whole to the power 4 into time taken. Time taken is 600 seconds divided by 8 into length is 0.2 into volume is 5 into 10 to the power negative 5. When we solve for this, we will get an answer 0.00181 Newton second per meter square. So this is the coefficient of viscosity of alcohol. Let's move to the next question. Find the volume of water that will flow per minute through a pipe of a diameter 4 centimeter and length 200 meter when the pressure of 5 Pascal is applied. Assuming that the flow is streamlined, find the and the viscosity of water is 0.001 in the SI unit. So what are we asked to find? We are asked to find the volume of the water which will flow per minute. So we are asked to find the volume of the water. Water is what we need to find. We are given the time of flow is per minute, say 60 seconds. And also, what are the information we have? The diameter of the pipe is 4 centimeter. If the diameter of the pipe is 4 centimeter, then its radius is 2, half of that, 10 to the power negative 2 meter. And we have length as 200 meter. Then the pressure difference is given as 5 Pascal. Pascal is again the SI unit of pressure, so you didn't need to change it. And the viscosity of a water is given as 0.001 in the SI unit. So it is Newton second per meter square. So what you just need to do is substitute into the equation. We have the equation Q, which is volume rate of flow, that is volume by time, is equal to pi p 8 to the power 4 divided by 8 L eta. Therefore volume is nothing but pi p 8 to the power 4 divided by 8 L eta into T. We can substitute for that 3.14 into 5 Pascal. A is nothing but 2 into 10 to the power negative 2 meter whole to the power 4 into time is 60 seconds. 8 into length is 200 meter into eta is 0.001. And when you solve this, you will get the volume of water as 9.42 into 10 to the power negative 5 meter cube. So this much water is flowing per minute through that capillary tube. Next, move on to the next question. Water is flowing from a constant pressure head through a horizontal capillary tube at its bottom. The tube is 49 centimeter long and 1 millimeter diameter. In 20 minutes, 200 gram of water flows out. Find the height of the pressure head. Eta of the water is given as 0.001 Newton second per meter square. So what is the question? We have a capillary tube which is fitted at the bottom of, we have this capillary tube which is fitted to the bottom of some kind of a tank, and this tank is maintained a constant height. That is, no matter how much water flows out, the tank is being filled again and it is maintained at a constant pressure, which means that this height is always the same. This height difference between the tube and the head never changes. And what we are asked to find is also this height. So this height is what we need to find. So what are the other information given to us? The tube is 49 centimeter long. That is, length of the tube is 49 into 10 to the power negative 2 meter. It is 0.1 diameter. Therefore, the radius is 0.5, half of 1. It is 1 millimeter diameter. So, the radius is 0.5 into 10 to the power negative 3 meter. And it is given that on 20 minutes, that is 120 seconds, 200 grams of water flows out. For this equation, the Poiseuille's equation, we want the volume in meter cube. So, we need to convert gram into meter cube. For water, 1 meter cube is equal to 10 to the power 6 gram, or 1 gram is equal to 10 to the power negative 6 meter cube. Therefore, 200 gram is equal to 200 into 10 to the power negative 6 meter cube. So, we can convert 200 gram as 200 into 10 to the power negative 6 meter cube. Eta is already given. What we need to find? We have the equation, that is V by T is equal to pi P e to the power 4 divided by 8 L eta. And the pressure, here is the pressure difference between these 2 points. Let's consider atmospheric pressure to be 0. So, here what we have is the atmospheric pressure. Here we have is atmospheric pressure plus the pressure of the water column above this, and that is H rho G. And when we need to find H, we have the answers for rho and G. So, let's substitute for that. V by T is equal to pi H rho G a to the power 4 divided by 8 L eta. So, let's find H from this equation. From this equation, H is equal to 8 L eta V divided by pi rho G e to the power 4 into T. We can substitute for that. 8 into length is 49 into 10 to the power negative 2 into rho is 0.001 into V, volume is 2 into 10 to the power negative 4. That is 200 into 10 to the power negative 6 can be written as 2 into 10 to the power negative 4 divided by pi 3.14 into rho. Rho is the density, and we know that density of water is 1000 kilogram per meter cube, because it's given water, density of water is always a constant and it is 1000. So, density of water, rho of water is constant, it is 1000 kilogram per meter cube, into G is 9.8 and A is 0.5 into 10 to the power negative 3 whole to the power 4 into time taken is 120 minutes, I guess. Sorry, it is 20 minutes or 1200. So, it is 1200 seconds. So, when we solve for this, we will get an answer 0.3398 0.7 meter. So this height has to be 0.3397, that is around 33 centimeter height, so that we can maintain this flow. Next question. Glycerin flows steadily through a horizontal tube of length 1.5 meter and radius 1 centimeter. If the amount of glycerin collected at one end is 4 into 10 to the power negative 3 kilogram per second, what is the pressure difference between the two ends of the tube? Density of glycerin is 1.3 into 10 to the power 3 kilogram per meter cube, and eta of the glycerin is 0.83. So let's solve the problem. It's pretty easy. What all we have, L is given. This problem is direct. We have a radius given. A is 1 centimeter, 10 to the power negative 2 meter. Then it is given the amount of glycerin collected at the end is 4 into 10 to the power negative 3 kilogram per second. So this indicates that the volume amount is not indicating to the volume, it is indicating to volume per time, because the unit is kilogram per second. So what we here given is Q, that is the rate of flow is what is given, that is volume by T is directly given as 4 into 10 to the power negative 3 kilogram per second. What we need to find is the pressure difference. We have density, rho is given, and also the glycerin, eta of the glycerin is given. So let's find the equation. We have Q, volume rate of flow, is given by pi p e to the power 4 divided by 8 L eta. So from this we can write equation for pressure as Q 8 L eta divided by pi e to the power 4. Q is given as 4 into 10 to the power negative 3 into 8 into length is given as 1.5 meter. Eta of the glycerin is given as 0.83 divided by pi is given, pi is 3.14 and the radius A is 1 into 10 to the power negative 2 the whole to the power 4. We didn't need to use rho here. Rho is not needed for this equation, and when we solve for this we will get it is 9.9 into 10 to the power 2 Newton per meter square, that is nothing but Pascal. This is also Pascal. You can write it in any unit you want, both are SI units. So the answer is 9.9 into 10 to the power 2. So the pressure difference between the ends of the tube is 9.9 into 10 to the power 2. Next question. 0.0314 centimeter cube of liquid flowing out per second through a capillary tube of radius 1 millimeter. Calculate the velocity of the liquid at the point. There are 3 points given. One is on the axis of the capillary tube. Next is adjacent to the wall and also 0.5 millimeter from the axis of the tube. We know that when water flows through a capillary tube, when we plot a velocity, distance, graph, velocity versus x graph, we will get a plot like this, where we have maximum velocity at the axis and zero velocity near the walls. We have seen this while we were learning the capillary flow, and this is the plot we will get. We have maximum velocity at axis and zero velocity at the walls. So what we are asked to find is velocity at this point, that is at the axis. Velocity at the walls. Velocity at the walls is 0 always. And velocity at some point, some distance, 0.5 millimeter from the axis. So we have an equation for velocity. Velocity equation is given by P by 4 eta L into a square minus x square. This is the velocity function, and here we need to find this velocity. What are the equations given? What are the values given? Let's say there is volume given. So volume is given as 0.0314 centimeter cube. So we need to convert centimeter cube to meter cube. So 1 centimeter cube is 10 to the power negative 6 meter cube. So it is 0.0314 into 10 to the power negative 6 meter cube. And the radius is given. The radius A is given as 1 millimeter. So 1 into 10 to the power negative 3 meter. So this is what we have in this equation. But we need to calculate for this value of V, and we do not have functions or the values for these values here. We only have the value for A, and we need to find a different x. But we do not have value for pressure or eta or length, etc. But it is given that the velocity or the liquid flowing out per second, that is volume rate of flow, that is Q, volume flowing out per second is this. And we have an equation for volume rate of flow as pi p a to the power 4 divided by 8 eta L. So why don't we substitute value for this from this? So from this, let me write P by 4 eta L. From the equation this, when I separate out only P 4 eta L, what I am left with is 2Q divided by pi a to the power 4. So I am substituting it back to the velocity equation, and my velocity equation will become 2Q divided by pi a to the power 4 into a squared minus x squared. So let's substitute for different values at the axis. At the axis, we have x is equal to 0. So x is 0 at the axis. When x is 0, v is nothing but 2q divided by pi a to the power 4 into a square. So it is 2q divided by pi a square. Let's substitute the values. 2 into q is 0.0314 into 10 to the power negative 6 divided by pi 3.14 into a squared, that is 1 into 10 to the power negative 3 the whole squared. And the answer for this, you can see, you can cut off these two. 10 to the power negative 3, 10 to the power negative 4 cuts off, we have 3.14 here, we have 0.0314 here, and also a 2 here. So the answer is 2 into 10 to the power negative 2 meter per second. So this is the velocity at the axis. So second case, at walls. At walls, we have this equation. At walls, x will become a. So a square minus a square, and the velocity will become 0. So at walls, x is equal to a. This implies that velocity is 0. Third case, at a distance x is equal to 0.5 millimeter from the axis of the tube. So we can calculate velocity 2q divided by pi a to the power 4 into a square minus 0.5 into 10 to the power negative 3 the whole squared. By substituting the values and solving for this, we will get the answer as 1.5 into 10 to the power negative 2 meter per second. So we have maximum velocity 2 into 10 to the power negative 2 at the axis, and the velocity decreases as the distance increases to 0.5 millimeter, and it becomes 0 at the walls. Next question. Two capillaries AB and BC of the same length are joined at the end at B, have radius r and 2r respectively. A is connected to a vessel of water giving a constant head of 0.17 meter, and C is open to the air. Calculate the pressure. So we have two capillary tubes AB and BC connected in series. So this could be the picture. So they are connected end to end at B, and they have a radius r and 2r, and A is connected to a vessel which maintains a constant pressure head, that is, this height is always 0.17 meter, and we need to calculate the pressure at B when C is open to the air, that is, the pressure at the C is atmospheric pressure. So what we know is the volume flow, so the rate of flow through the capillary tube AB should be same as the rate of flow through BC, because same amount of water comes out of it. Therefore, Q should be same for both these tubes. The water flowing through AB should flow through BC also. So the volume rate of flow will be the same. So we have an equation, Q is equal to pi P e to the power 4 divided by 8L eta. From this, we know that let's assume that the pressure at B is a small p. So the volume rate of flow, the pressure difference between these 2 points, here at this point we have a pressure due to the water column above it given by H rho g, and the pressure at B is P. So the pressure difference is the difference between these two, and the pressure difference at C is P minus 0. When we take the atmospheric pressure as 0, it is just P. So these we can equate the volume rate of flow equation of the capillary tube AB to the capillary tube BC. So it is, for AB we have pi into 0.17, because it is maintained at a constant head of 0.17 meter minus P, the pressure, into A. A here is r to the power 4, this for the tube AB, into 8L eta. This is for the tube AB, and the volume rate of flow for the tube BC is pi. The pressure difference is just P, and the radius is 2r. So 2r to the power 4 divided by 8L eta. We can cut off the constants and write 0.17 minus P is equal to 16. We have 2 to the power 4, 16 P. So from this equation we can solve for P. P is the pressure at B is 0.17 by 17, that is nothing but 0.01 meter. So the pressure head at this point is created by a 0.01 meter head. So if the pressure at A is created by this head at a height 0.17, the pressure at this will be created by another height, that is 0.01 meter. So pressure at this point is equal to the pressure which is created by a water column of height 0.01 meter. If we are given with the rho, that is what type of liquid is flowing, say if we have given that the liquid flowing through is water, then we have the equation for rho as 1000 kilogram per meter cube. We already know that, and we can substitute for G also, and we can find the pressure at the exact pressure at this point. Since we do not have this information in the question, we should say that the pressure at B is equal to the pressure created by a water column of height 0.1 meter. Hope I am clear for you. Let's move on to the next question. The next question, a vessel of cross section 0.02 meter square has at the bottom a horizontal capillary tube of length 0.1 meter and internal radius 0.0005 meter. It is initially filled with water up to a height 0.2 meter above the capillary tube. Find the time taken to empty 1/2 of its contents. Coefficient of viscosity of water is also given. So let's try to understand this question clearly. So what we are asked to find is time taken. So what is the given scenario? We have a vessel. So here we have a vessel, and cross section of this vessel is given to be 0.002 meter square. So this is the area of cross section of this whole container. Okay. Then there is a horizontal capillary tube of length 0.1 meter and its radius A is equal to 0.005 meter. It is initially filled up to a level h is equal to 0.2 meter. 0.2 meter above the capillary tube, and we need to find the time taken to empty 1/2 of its content. That is, what is the time taken when the height h becomes 0.01 meter. So we have two heights, say h1 and h2. So initially water was at the level H1, and as the water flows, the content becomes half, that is at H2. So what will be the time taken? For the equations we already have, that is the Poiseuille's equation, we are dealing with a constant pressure. You remember the equation was for when the capillary tube, the pressure between the ends of the capillary tube is at a constant pressure. But in this case, as the height of the water column decreases, the pressure at this end decreases. So the pressure difference between these 2 points are no more constant. Therefore, we cannot use the equation, that Poiseuille's equation, directly in this equation, because Poiseuille's equation was for when the pressure difference during the time t is kept constant. For this case, the pressure difference changes because the height of the water column is decreases with time. So the pressure difference between these 2 points changes with time. It changes with as the height of the water changes. So we need to find a way to calculate the time taken. Let's the time taken be a small amount of time taken be dt. And we say the water which flows out at this time dt is dh. That is, at time dt the height has decreases to h1 minus dh. When the height is decreased to h1 minus dh, the volume of water decreased. That is, volume of water which flowed out will be equal to this area of cross section into height. Am I correct? I repeat, let a time dt, and let's see that the height difference occurred at the time dt is dh. That is, at the time dt height has decreased to dh. The height has decreased to dh means this amount of water has flown out of this capillary tube. So how much water has flown out of this capillary tube? This is the water contained in this area, and it can be calculated as base area, which is already given as A, into the height dh. Therefore, the rate of flow of water, I am writing rate of flow of water, that is volume rate of flow. How much volume of water has flown down at a time dt? How much is it? It is A into dh by, since it is rate, we have dt. So A into dh is the volume of the water which has flown out at a time dt. And we know that dh by dt is negative, because as time increases the height decreases. So since as the time increases height decreases, dh by dt is negative. Now let's equate this equation to the Poiseuille's equation, because we already have an equation for volume rate of flow of water, and we have found the volume rate of flow for this particular scenario. So let's equate it to the Poiseuille's equation, that is A into dh by dt is equal to Poiseuille's equation, pi into pressure. The pressure P is H rho G into 8 to the power 4 divided by 8 L eta. Now this is our equation. From this, what we are asked to find? We are asked to find T. If we need to find T, we need to integrate. So let's write an equation for t first, that is dt is equal to minus 8a L eta divided by pi rho g e to the power 4 into dh by h. On integrating, let's integrate. On integrating, dt becomes t. All these functions are constants, so it is minus 8a L eta divided by pi rho g e to the power 4. All these are constants, and what we are integrating is just dh by h. So we are integrating dh by h from which number? It is from h1 to h2. So we have this equation dh by h. What is integral dh by h? It is log to the base e, higher limit minus lower limit. So time taken, t will become minus 8a L eta divided by pi rho g e to the power 4 into log to the base e, upper limit h2 minus log to the base e h1, or we can write it as by taking minus inside, we can write this equation t is equal to 8a L eta divided by pi rho g to the power 4 log h1 minus h2. When I take this negative sign inside, I will get log to the base e h1 minus h2. It will be shifted, and log to the base h1 minus log to the base e h2 is nothing but log to the base e h1 by h2. Okay, now we don't know how to solve for log to the base e, so we'll just change the base to 10, log to the base 10. To change the base, we just need to multiply it with a constant, that is 8a L eta divided by pi rho g e to the power 4 into 2.303. That is when I change it from log to the base e to log to the base 10 h1 by h2. And I know that h1 is 0.02 and h2 is 0.01. That is h1 by h2 is 0.02 meter divided by 0.01 meter, and that is 2. So my equation, again I can substitute the values. 8 into a is already given 0.002 meter square, length is given as 0.1 meter, eta of water is 0.001 Newton second per meter squared divided by pi is 3.14, rho of water is 1000, it's already known, g is 9.8 is already known, that is radius of the tube is given, radius of the tube is given as 0.005 meter, so to the power 4 into 2.303 log to the base 10 of 2, and the answer for this question is 576.2 seconds, which is almost equal to say 9 minutes and 36 seconds. I'll repeat the entire process. we are given with a scenario in which the pressure difference between the pipe, that is the capillary tube, changes with time, and this change is corresponding to the how much water it flows out. So we need to find an equation for rate of flow of water in this scenario, and we need to equate it to our Poiseuille's equation. So the rate of flow of water at this case, when at a time dt, if dh is the height of the water which have flown out, then the amount of water which have flown out is A into dh. Therefore, the rate of change is A into dh by dt, and with a negative sign because rate of flow always decreases with time. And we can equate it to the Poiseuille's equation. We integrate and find an equation for t. We substitute the values and will get the answer as 576.2 seconds. Next question. A tube of radius r and length L is connected in series with another tube of a radius r by 2 and length L by 4. If the pressure across the two tubes are taken as P, find the pressure across the tubes separately. So the question is, if the pressure across these two tubes entirely is P, we need to find the pressure difference between the individual tubes. Okay, so we know that the entire pressure difference P will be the linear sum of P1 plus P2. So P1 plus P2 will be the pressure difference between these two ends. So and also we know that the rate of flow between these two tubes will always be the same, and we have an equation. The water flowing through this tube have to flow through this tube also. So the rate of flow between these two are always the same, and we have an equation for rate of flow given by pi p r to the power 4, or sorry, a to the power 4 divided by 8 L eta. So for the first tube we have pi, we do not know the pressure but we put it as P1, and the radius of the first tube is r to the power 4 divided by 8 eta, and its length is L. And this rate will be same as the rate of flow of the second tube, and it is pi P2 because it's second tube, and its radius is r by 2 as given in the question. R by 2 whole to the power 4 divided by 8 eta into its length is L by 2. So let's solve for the equation. We have let's cut out the unimportant parts here, and we can find P1 r to the power 4 is cut out already, and P1 is equal to P2 divided by 2 to the power 4 into 2, that is P1 is equal to P2 divided by 8. P1 is equal to P2 divided by 8, or we can write P2 is equal to P1 8 P1. P2 is equal to 8 P1. We already have an equation here connecting P1 at P2. So substituting this to this equation, we will get P is equal to P1 plus 8 P1, that is 9 P1. This implies P1 is P by 9. And also using the same equation, if P1 is P by 9, then P2 from this equation is 8 times P1, that is P by 9. If the length was not L by 2, since if the length was L by 4, suppose the length was L by 4, then we will use the equation L by 4 and the relation between P1 and P2. Suppose if it was L by 4, the relation between P1 and P2 will be like P2 is equal to 4 P1. In this case, we will have P1 will be equal to P by 5 by substituting to the first equation, and P2 will be equal to 4 P by 5. So, let us see in this equation what happens, or which one has the highest pressure. The pressure on P2 is the highest. That is, pressure difference between these 2 points is highest than the pressure difference between these 2 points. And also we can see that the pressure difference increases as the length decreases. When it was L by 2, the pressure difference was 8 P by 9, but it was when L by 4 it increased to 4 P by 5. So as the length decreases, the pressure difference increases, and as the width, that is the radius, increases, the pressure width decreases. Let's do something in combination with the same question. What if we have different tubes connected at the same level? That is, instead of being connected series, we have it is connected parallel. That is, it is connected at the same height. Both these are at the same height, that is connected parallel to this plane. If both these are connected at the same height, that is, the pressure difference between these 2 points are same. If the pressure difference between these 2 points are same, because their height is the same, then let's see what happens. Let's see what if this has a radius r and if this has a radius 2r. What will be the rate of flow? Just for imagination, let's see what will be the rate of flow. We have the rate of flow Q is proportional to a to the power 4. So, for the first case, it is a to the power 4 because all the others are constant. So, since it is a to the power 4, let's see for the V1 by V2 will be equal to a1 to the power 4. It is 2r to the power 4 divided by r to the power 4. It is 2 to the power 4, that is 16. So, flow at V1, that is flow through the out of this V1 will be 16 times greater than that of V2 when we have just doubled its radius. So, it is 16 times greater V2. Let's do the next. When here the difference is in length, that is when this tube one has a length L and this tube is L by 2. So, we know that Q is inversely proportional to length. So, V1 by V2 is L2 by L1 and L2 is L by 2 and L1 is L, that is the answer is 1 by 2. So, we have V1 is V2 is equal to 2 times of that of V1. That is a rate of flow through V2 is 2 times of that of V1. 2 times water flow out of V2 at the same time when a small amount of water flow through V1. And let's try another combination with both these, that is when its length is 2r and its radius length is 2l and its radius is 2r, while the second the length and radius is half. Let's see, we have an equation q is proportional to a to the power 4 by l. So v1 by v2, for v1 it is a1 to the power 4 divided by l1 into l2 divided by a2 to the power 4. Here a1 is 2r to the power 4 divided by r to the power 4 into length L2 is L divided by 2L. So it is 16 by 2 or 8. So flow through V1 is equal to 8 times of that of V2. So I guess we have discussed almost all the questions possible from the chapter we have learned. Let's see with another question set from surface tension in the next video. Thank you.